All right, so here's an example of some relative motion, and we're going to work on finding velocities using the information we're given. And we have two spaceships. One is flying towards the other, and we don't know what the relative speed of the spaceships are, but what we do know is Spaceship A fired a missile at Spaceship B, and Spaceship A fired the missile at 0.75 c, the speed of light, and B is perceiving the incoming missile heading towards it at 0.95 c. And one of the ways to do this is you've got to decide who's sitting still and who's moving. And so in this case, I'm going to think of Spaceship B as the stationary object. And going back to classical mechanics, when we had relative velocities, you had the relative velocity is equal to the velocity of the moving object plus the velocity that was projected from the moving object. And so what we're going to look at is the relative equation for this. Since we do have relativistic speeds, we have to use a relativistic equation. And in this case, V is going to be what we're looking for, the relative velocity of A as observed from B. And then the U prime is the velocity of the missile from A's point of view. And U is the velocity of the missile from the stationary point of view. And so we have that equation, and then we plug in our values, and we'll end up doing some algebra. You can do your algebra however you like. I personally like to cancel things out and get rid of denominators as fast as possible. But when you crank through all the algebra, you end up with a value for the relative velocities of 0.697 c. Alrighty, bye-bye.